So hi developers, you most likely have come across this thing we call the equals, the two equal sign, and the dot equals operator. Most of the times, even in interviews, they ask when you're comparing two strings, and you remember there are two ways of creating strings which you look at, and you're asked, so what would be the output for this? So you have a string, say for example, hello, or Java programming, and another string, Java programming, and you're asked, what would be the output of comparing these two strings? Is it gonna be an equal, or is it going to be a true or a false? You get. So we definitely have an understanding of what happens. But nonetheless, I have this article that I'd written a while back, and it's about the string pool, hash codes, and kind of a performance guide when it comes to working with strings. So the first thing that we definitely going to talk about is what strings are. So string is just like ideally a collection of characters. So and for these characters, it could be numerals. It could be ideally anything that is enclosed in between the two double quotes. So they are very important, and there is one aspect that is very important as well when it comes to strings, which is immutability. And we possibly would look at what do we mean when we say that a string is immutable, for example. Yeah, so string handling is one of the most fundamental aspects of Java. Yet it's kind of, I'm not really sure, but misunderstood. The way Java manages the string through the string pool mechanism, combining it with the intricacies of the idea of hash code. So, what happens with hash codes? How are they involved in this whole process? And yeah, so the first thing that we look at, so I'll just bring this idea over here, is we have this one here. So ideally a string, what a string would look like, and the kind of operations that you expect from a string. So how to create a string? There are various ways using the literal way. So this is a literal way of creating a string where you say string name equals to, and then the quotation marks, and then you give it the value there. And remember, a value could be anything. We have ways of concatenating a string. We also have useful methods when it comes to a string, but this is not why we're here. So why we are here is to try and demystify these concepts that we are looking at here, which is one, the string pool. So a string pool, ideally, is also known as the string constant pool. So for this one, you can check out the official Java specification of strings, and they have a bunch of things there that you could look at. So, or the Spring intern pool is a special memory region within the Java heap where the JVM stores string literals. So that is where, whenever you say string name equals to Java, that is where the string is stored. So when you use the literal way, they're stored in the pool. And then this mechanism is Java's way of optimizing memory usage for one of the most commonly used data types in programming. So even a production grade application, like it definitely uses a string, but how we create these strings is kind of important. Yeah, so when you create a string using a literal, like hello, Java doesn't like simply allocate new memory to it directly. So instead it follows the following process. You get. So you're using the string literal, remember. So the first thing it does is checking the pool. So here the JVM, where we have the hotspot JVM, yeah, which is the under the hood JVM that does the magic for us, searches a string pool for an existing string with identical content. But now, how then does it check? Because we tend to understand that when you're performing a check in a string, it's gonna take an of n, but we want it to happen faster. So what it uses to search is the idea of a hash code. So when you search with a hash code, it gives you like instantly whatever it is you're searching for. Kind of how hash maps do search. So you get an O of one in search. So you also have the reuse or create. So if found, it returns the reference to the existing string. If not, it creates the new string and add it to the pool. So if you're working with, say, for example, string name equals to Java and the string pool is currently empty, so it's going to put it there. And if it is Java is found there, you calculate the hash code, it returns there. It's now the new string that you're creating points to that one that is already in the pool. So, and then afterward, it returns the variable. The variable receives a reference to the pool string object. Okay, so what this approach does, it ensures that the identical string literals, they share the same memory location, significantly reducing the memory consumption if you have like a bunch of strings in your application. So how the memory architecture looks like, one is it resides, there are two types of memory. We have the stack memory where your method calls or the stack frames reside. and also the variables reside there. But now, when your objects are created, where they reside is where what we call the heap memory. So the heap memory, since Java 7, this is where the string pool resides. When it was moved from the PAMGen space, PAMGen also was later replaced by the meta space. So where you have the metadata, I presume. So this change improved garbage collection efficiently and overall the memory management. So the pool functions as a hash table, storing and retrieving string literals based on their content equality, allowing reuse of immutable string objects. So this here a hash table. So lookup time is O of 1. So whenever we want to add a string using the literal way, we have to check our pool. Does this pool contain the string? But again, like I said, when you want to perform the check, you have the check needs to be very faster and optimal. So what we do, we use a hash table for this case. And you understand hash tables have a O of 1 in terms of lookup time. Yeah, so this is how the pool looks like. So this is the heap memory, and then we have a pool. For this case, we have the word hello and wal because they're two different words. Ideally, you should now have understood that we're using the literal way. And then this is now the regular object space. So this is when you create a string using the other way, using the new keyword, for instance. So if you use the new keyword to, I don't know if I have a sample here where I use the new keyword. Yeah, say for example, you say string a equals to new string and then you use hello. So this one here is stored in the other memory. And then yeah, there's the creation mechanisms which we already talked about, so I won't dive into it. We have these ones. You create the literal way and then they are stored in the pool. So Java programming, this one also will be you still concatenating during compile time, but it's still gonna end up being Java programming, so it's gonna stay in the pool. So you look at this when we have our heap, it's gonna be here. The pool, in the string pool, we have the word Java programming. So string 1, 2, and 3 will all point to the word Java programming. I hope that makes sense up to this point. And then so let's just look at an example. I have a bunch of code here that I want us to try out. I want to show you to demonstrate how this thing would look like. So I'll take a string pool here. I just want to see. I just want to take the method. This is not what I want. I don't know if I have it here. Okay, cool. So what we'll do is I'll just create here in the IDE because my IDE currently has an issue. I'll just say string name equals to, let's just say a equals to Java, like that. And then what I'll do is I'll just duplicate these things like that. I have B, then here I have C. So what I want to do is I want to check whether they kind of reference to the same thing. So what I'll do is I'll have an S out here. So I hope Copilot would help me. I'll just use the system dot identity hash code like that. And then I want for A like that. And then what I'll do now is I'll duplicate, and then take for B, and then C. So this shows us that this just wants to prove that they reside in the same memory location. So I'll just paste it here like this, and then okay. Oh boy. Okay. So let me just run. I hope it's gonna run. Yeah. So you can see they all belong in the same location. So this is they all again this is the hash code. Let's just see identity hash code. Yeah, returns the same hash code for the given object as would return default hash code. Yeah, it's a native call actually. Hash code. So they all have the same hash code. So let's try something different. Let's try something different. Let's try just for vibes and inshallah. D equals to new string like that. So this is the other way of creating strings. And then say Java. So just forgive the formatting there. Now, but alternatively, I can just oh boy, that. And then I could just do duplicate. Is it? No, it's not it. So I'll just copy this, paste it here, and paste it. Let's see if they get the same hash code. And you see they get a different hash code. So yeah, this is ideally one. I'm just trying to see how to retrieve the memory address. Let's see if we have a way of retrieving it. Do I have that really? I'm not sure whether I have that. I just have the identity hash code. Yeah, so that's what we have currently. Okay, so on to the next thing. This is now the thing I've just done here. When you use the new keyword, it explicitly forces the creation of a new string into the heap space. So we have in the pool string 1, 2, and 3 are pointing to Java programming, and then now 4 and 5 new objects will be created. And now you see this is gonna be kind of memory uh, not good because we are ideally creating new objects in the heap memory, and that consumes a lot of memory at the end. So each call to the new string creates a distinct object, even if the content is identical to the existing strings in the pool. So runtime string creation. So strings created through runtime operations, e.g. concatenation with variables, methods, returns, etc., are not automatically added to the string pool. For example, you have this one. This one is one way. We have part one, part two. So this one is created at runtime. Yeah, and this one at runtime. This one means that this would also be a runtime concatenation. Okay, unlike what we had here, this one is a compile time concatenation. So there's a difference between those two. Uh, yep. So that means that this combined would also be in the heap, not in this other memory location. We'll look at this the intern method. So it provides a way for you to manually add strings to the string pool or retrieve existing pool strings. So when you do this dot intern, so when I do something like this, when I do something like this to this one, like that, what it will do is they'll now kind of have the same memory. Yeah, they're all stored in the same memory. So that one is another way of doing. Okay, so it checks if a string with identical content exists in the string pool, ideally to how the others are just doing. If yes, it returns a reference to the pool string. If no, it adds the current string to the pool and returns its reference. So it's particularly useful when dealing with strings created at runtime that you want to deduplicate. So the concept of hash codes, this is what we've already looked at, where we have the system.identity hash code. So content-based hash code. So this is the standard hash code implementation that's based on the strings character content. So based on the strings character content. So this is very important. So hello and this hello, they're gonna have the same. So it's based on the string character content. So if I do something like this, this Java here, I hope this thing is very legible. So if I put an S out, for example, and then I say here, a dot hash code, for instance, that this like that, and then I can also do the same for B. So let's just see. B. Yeah, so these are two different things now. Like they are different from this system.identity hash code. So this a.hash code is the hash code method that exists in the string class. So this one is based on the characters or the literals that we have. So they have a different one here. But now this one, we look at it. This is what we're going to look at next. But ideally, you get a concept. So the formula for getting the hash code is normally S at 0 power 31 is kind of the magical number in Java when it comes to dealing with prime factors. But you can see here, S at I represents the character at index I, N represents the total number of elements, and 31 is the chosen prime number for the optimal hash distribution. So it's normally the prime number that is picked for the calculation of the hash distribution. So we also have the identity hash code. So this hash code is based on the object's memory address. So what do we mean here? we're just trying to get where it is stored in memory. That's the hash code of where the memory is at. We have this string one, it's hello, this one is hello, but when we print them out, we get different hash codes. So an example is what we have here. So I'll just put here. Actually, ideally, I should be using io.println because this one is already abstracted for us. Yeah, like that. Just to make this Java thing a bit more interesting, you know. And then io.print line like that. And then here I'll just say something like system identity. Okay, for me, like that. So this is for the new one, and this is for the other one. So this one is for the literal. Literal. Okay, so I hope this kind of makes sense to you. So you'll see that we have there's a semicolon that is missing. Yeah, you see the system identity for the literals is this. For the new is this. Okay, it's similar because of the intern method. So I'll just remove it. Yeah, so you can see that they are stored in different memory locations. So this one is stored in the string pool. This one is stored in the other space, the heap. So objects in the string pool with identical content share the same identity hash code, while the one in the new have their own identity. I will not talk about this for the hash code caching. So string objects cache their hash codes for performance optimization. So the first time hash code is called, the value is computed and stored. Subsequent calls return the cached value without recalculation. So this optimization is safe because strings are immutable. So yeah, that's just it. But we won't like do a deep dive in it because it's a bit of yeah-ish method. And then now on to the meat of the day. So when you're doing comparison, so what normally happens? So when we do equals operator, this equals this operator, the reference comparison. This one, the operator compares the object references. So where are they at in memory? Are they pointing? Are they pointing to the same thing in memory? That's the whole thing. It doesn't compare the content. So this one doesn't compare the content. So when you say string A equals to hello, string B equals to hello, and then string C equals to something like this one. So these two have the same reference because they are all in the pool. Remember that. So once we do system.identity hash code, these two would give us the same thing because they are pointing to the same thing in memory. We are not comparing the value, remember. So here we'll get a true for comparing the two strings. But now when we compare either with this, the one that uses the new keyword, we get a false because they have the different system.identity hash code. So they are in different places in memory. One is in the pool, the other one is now the general heap. This here. The other one is in the regular object space. You get. So that's the whole difference. And yeah, so whenever you want to compare the actual values, never use the this one, the reference comparison. Always use the dot equals method. So this one here compares the actual character content. Very, very important. So that one compares the actual character content. So I'll just remove this one here, paste the here. Let's compare comparison like that. So I'll just say io.print ln like that. Let's compare C and B. C equal to B like that, and then I'll just copy this, paste it there, and then C equals to D. Let's just compare them. So this one we expect should give us a true because they have the same identity. They're stored in the pool. Now, because this one is in the regular object space, we expect that we get a false comparing it with D. So let's see. Okay, so what's the issue? IO. Okay, cool. Sorry, my bad. Yeah, so we get a true and a false. But now, when we want to compare the actual content, is for C and D, is we just say io dot print line like that, and then say C dot equals equals. So here we expect true like that. Gonna be a true, true, false. Yeah, true, false, true. So you're gonna give us a true. So that's how we're supposed to compare. The content comparison, yeah. So this method checks for the should always be used for logical string comparisons. Very, very important. Yeah. So ideally, that's the most important thing you kind of need to understand when it comes to this. This other content here is just a bonus. I was just trying to kind of explore how the runtime would be affected in terms of the storage, space, and whatnot. And also, string literals are faster to create because they might already exist in the pool. So that might. Uh, but this one is always created. Is always created. But it's just something that is very negligible. I'm not really sure where you'd kind of try and look that. But nonetheless, it's just like quite important that you understand how and when to use this thing here. When to use the new is explicitly when you need a new instance. So when you need a guaranteed new object, interfacing with kind of, say for example, legacy APIs. Some APIs require distinct string instances, and then security when you need to ensure that there is no shared references. Uh, so there's this concept of defensive copy, which is quite nice. Yeah, and then this is how you're supposed to do. Uh, yeah, this is good. This is good. This is how you're supposed to do your checks. And if you care about null safety, you can do object.equals. So in most of the code bases, like the core, there's you'll normally see something like this object.equals when they're doing comparisons. So yeah. This one, the intern method, when you want to kind of deduplicate with many similar things. So, for example, reading many similar strings from a file. So you can deduplicate them. Here you say string.intern. After you trim them, you can just intern so that all of them would point to the same. So you don't have like a function. Yeah. Okay, so the others are just like takeaways. You can get the article here, read it, and share your experience with how it is. The repository is also here. I have linked the repository somewhere around that contains all this information that we've talked about. So here's the repository, so you can look at it and share your feedback and your learnings as well. So I was trying to kind of do a bunch of checks with how you create strings. Like for this case here, we were creating using the new keyword like that. And then this other one, we were creating using the literal way. So just trying to compare how they are using the runtime metrics here. All right, so thank you so much for watching up to this very end. I hope you learned a thing or two out of this. But if you forget everything, just remember, when you want to compare the actual content of strings, use the dot equals. But if you care about the references, just use the two equal signs. Yeah, till next time, have a lovely day.